is Carlo Pagano. I am an Italian mathematician. I studied originally in Italy. I did my master and undergrad there, and I finished my PhD in the Netherlands, in Leiden. And I spent 3 years here in Max Planck after that as a postdoc, and then 1 year at Glasgow, University of Glasgow, and then I started a tenure track position in Concordia University, Montreal. I'm a number theorist. I've been interested in number theory as soon as I got interested in mathematics, and that somehow never left me. That interest, and I'm interested in the subject very broadly, but especially I would say in Diophantine equations, and so equations to be solved with integers or rational numbers. And I often think about arithmetic objects in family and try to use ideas from probability theory and other areas to say interesting things about either families of arithmetic objects, or sometimes also to construct individual arithmetic objects by using probabilistic ideas. I am the most proud of 2 joint works with Peter Koymans. He's a collaborator of mine. We worked together since our PhD for almost 10 years now. And in one paper, we settled a conjecture of Stevenhagen on the solvability of the negative Pell equation. And in a different one, more recent, we settled Hilbert-10 problem over general finally generated rings. And yeah, those were 2 works I was definitely the most proud of. Yeah. I had quite a few inappropriate places where I had mathematical ideas. I think it's normal if you think long about a problem that then you relax your mind, you do something else. And I had it at night here walking in Max Planck. I had it while doing a move between houses in Bonn. And yes, I had a more recent one in Zurich while I was eating a goat cheese salad. And I was working with Peter on this problem on the Hilbert-10 question. And yes, so I'd say that I had quite a fair bit of these moments where somehow suddenly an idea comes or a thought comes, and I see that many people already notice that it's probably the effect of cumulative thoughts that when you relax the mind, sort of suddenly converge into something. Yeah, 2 examples of sort of this kind of thinking that comes in unexpected moments. One was in Zurich recently. We were struggling with Peter on our project, and we had some ideas, but there were a lot of difficulties, and we left each other at the tram station going down from ETH, and we sort of shared some initial potential thought, and I went with a salad, and I remember the things that Peter was telling me kind of were sort of working inside of me, and then I sort of something popped up, and I started scribbling, and then I ran on WhatsApp, and we started immediately chatting about it, and okay, it took a long time from there to work out everything, but that was a moment sort of where things twisted. And I have another one where I was with my first son that we were at night, and he couldn't sleep, and he was intermittently waking up and then falling asleep, and of course my sleep was gone, and I started thinking about the project, and sort of, yeah, I had a lot of ideas in that just lying in bed there with my eyes closed, and sort of it's a paper I'm still actually finishing up, but yeah, those are small examples of sort of mathematics coming in at inappropriate moments because you have thought already so much about it. think I would have, if I would have been a scientist, I would have been probably a neuroscientist. I actually got interested in math because I wanted to become a neuroscientist, and then I had to learn a bit of math as a teenager, and then number theory came in, and I got hooked and forgot about everything else. But if I wouldn't be a scientist, I would probably have tried to become a lawyer. That's definitely something that would have interested me a lot. Yeah. These days, they are depressingly narrow. I essentially mostly find time to work out, to get a bit uncomfortable at the gym. But I used to have fairly broad interests as a teenager and my early 20s, and like I read a lot, play the piano, and so on. But I found that with mathematics somehow it took over on everything else a bit, and I still manage sometimes to engage in those interests, but I think that at least for me, it's a bit that sort of research in mathematics makes you very demanding on what it is to understand something or to do something well, and then it becomes a bit hard again to do something so and so, and you become a bit too picky, and so I cannot enjoy as much as I did when I was a teenager, playing the piano a bit loudly, and I rather just go work out, and that's my main hobby at the moment. Yeah. Okay, yeah, I started recently thinking more about advice because I started having students, and what I find is very hard for me to give general advice, because even when I have two students, I find something that works very well with one student works really badly with the other student, and sort of you have to give opposite advice. You might think, okay, this depends on the individual student, and there is sort of one rule, and you just have to tell the rule, and then according to the student change it. But even that I find is not true. Like what is remarkable in mathematics is that you can make it work with many different approaches, many different talents, and you don't want to make very rigid rules that sort of pressure people into something that is different from their talent. So somehow I view it more like as an art that you try to do person by person and try to see what they are good at, and sort of try to squeeze their talent out of that. So I am careful with general advice. That said, I used a lot of general advice when I was younger. I remember especially Terence Tao as a full page of fantastic advice, and but even then I did with it a bit what I needed to do, and I wasn't too literal about it, and so I for that reason I will refrain from giving very general advice. It's fantastic. Yeah, I had the 3 years I spent here as a postdoc were probably among the most formative of my mathematical career, and you get to speak to like a lot of people, and people at your same level, people at much higher level. You go to lectures of fantastic mathematicians that tell you how they think about things in their field, and even if it's not your field. And it happened to me here actually once. I was struggling with some very ad hoc computations, and I went to a lecture of Danzayer where he explained how he would think about the Lie algebra for some completely unrelated reasons, and it turned out to be very helpful for what I was doing. So that's just a small example, but you get to see these sort of extremely good mathematicians explaining how they think about things, and at the same time you find a lot of peers as a young mathematician that are coming with a lot of good problems, and I started a lot of collaborations here, and it's just a paradise for mathematics, and for young mathematicians especially. It's a wonderful place. Yeah.